Mechanical engineering is considered the most diverse engineering discipline. A mechanical engineer can find work in almost any other engineering field since it is such a broad discipline. Mechanical engineering is one of the big four, the most engineering degrees awarded every year, next to civil, computer, and electrical engineering. The most common fields mechanical engineers work in are automotive, aerospace, spacecraft, energy, machinery, and manufacturing. Compared to other engineering fields, mechanical engineers work on machines, structures, devices, mechanical systems, and even energy conservation systems, basically everything we use daily. The most that overlap other disciplines can be found in civil, electrical, and chemical engineering. A mechanical engineer is one of the most well-rounded engineering disciplines since they are the middleman between other disciplines. For example, when looking at an airplane turbine, while an aerospace engineer works on the aerodynamics of the fan blades, the mechanical engineer designs the motor for the fan, and electrical engineers hook up power to it. More specifically, mechanical engineers observe the behavior of solid bodies under stress, vibration, and other forces in order to design and manufacture a better product. In this case, they would analyze the durability of the fan blades under stress. Further, they also analyze the behavior of liquids and gases to design systems such as the turbine or a piping system. Oftentimes, mechanical engineers need to apply thermodynamics, which helps them convert different forms of energy and is often used in power plants, engines, and ventilation systems. Overall, you could say they basically design all mechanical-based products and systems.
One very useful tool that mechanical engineers use for their work is statistics and data analysis. Statistics can help them calculate expected outcomes, analyze the efficiency of a product based on data, or predict the success or failure of a product. More precisely, statistics can be used to determine the waste produced by a certain machine based on the accuracy and number of units produced every day. This can help companies determine how much waste is produced and how it will affect their profit. Another useful tool is statistical inference, which helps mechanical engineers predict the success of a product or new design based on data gathered from a representative sample. It is also important for mechanical engineers to be able to determine variability to improve the design and create better designs overall. The drill bit in the video, for example, wears down and changes size the more it's used. The variability of this drill bit versus a brand new one could be determined using statistics. Statistical methods, such as finding averages, can be used to determine the cost per part based on how long the average drill bit or machine can be used for and how many parts it produces in its lifetime. Statistics can also help determine how many parts will vary given the capability of the machine producing it. This can be used to determine how many parts will be defective in the end. Finally, statistics is the most important part for risk assessment, such as how many parts will result in failure out of all the parts manufactured, and if a company can afford that loss.
Given this, it's clear that mechanical engineers deal with a variety of topics on a daily basis. In order for them to be successful in their job, they have to communicate with engineers from other fields a lot. This combined work occurs with electrical engineers when developing a new machinery and different system that requires electrical components. You see this a lot in cars because they have a lot of electrical components and sensors. Mechanical engineers need to work with the electrical ones to get it all working together. To calculate and design new ideas, mechanical engineers also collaborate with software and computer engineers who provide and develop programs such as CAD that mechanical engineers use every day, which you can also see in cars because cars do have software systems and they do have to communicate with the electrical and the hardware. In return, mechanical engineers provide software engineers with accurate calculations for realistic video games effects as well. They can work in many different fields.
A lot of cooperation includes working with chemical, electrical, and resource engineers when trying to find alternative energies. As part of the 14 grand challenges for engineering, making solar energy economical is one of their main focuses. At the moment, solar power is by far used less than it could be due to its high price-to-performance ratio. In regards to the grand challenges, mechanical engineers work closely with chemical, industrial, and nuclear engineers in attempting to provide energy from fusion. The problem with fusion is that the byproduct of uranium-splitting fission needs to be contained. It is particularly a challenge concerning mechanical engineers, since the knowledge of various engineering areas is required to design a way of containing the byproduct and provide clean and renewable unlimited energy.
Another challenge that is important for mechanical engineers to address is the restoration and improvement of urban infrastructure. They cooperate closely with civil and computer engineers to find ways of making our daily lives not only easier but also safer. One result of this cooperation was the emergency origami bridge created in 2015, which could be deployed in disaster zones with poor infrastructure. And finally, it is the mechanical engineer's duty to engineer the tools of scientific discovery, one of the other grand challenges. These tools vary anywhere from drones over Mars, robots, to flexible materials for our smartphone cases.